Okay, so in this video here, I'm going to show you how to find the correlation coefficient of a two-variable data set using Microsoft Excel, except we're going to show all the steps here like we would if we were doing it by hand. There are quicker tricks to doing this that you could use on Microsoft Excel, so if you're watching this and you're not enrolled in a data management course where you're being asked to do this, you might actually find this method really tedious, so that's fine. But this is for students who are in a class where they're expected to show their work for calculating correlation coefficient. So what we need to do here when we have a data set is we need to, first off, go through the steps to find the individual standard deviations of both the x variable and the y variable. So what I'm going to do here is I'm going to start by making it so that we have the sum. So I hit equals, sum, bracket, and then I'm going to highlight what I want and then close out the bracket. And I have that for x. Now what I'm going to do here is I'm going to carry this all the way over because we're going to need to calculate a whole bunch of things here. I'm going to calculate my x minus x bar, then then I'm going to need to calculate x minus x bar squared. Then I'm going to do the same thing here for y minus y bar, and then I'm going to do the same thing here for y minus y bar squared. And then the last thing we're going to want here is x minus x bar times y minus y bar. Now, if you're unsure why we have that, that's going to be for when we're calculating the covariance. So I've had this set up here. I've set up row 10 so that it's just going to calculate the sum of everything we're doing in here. So how do we calculate the standard deviation of x? The first step is to go x minus x bar. And I shouldn't say the first step. The first step is actually we've got to calculate the mean. So the mean of x. There's two ways of doing that. One is to just say, to take 41 and divide it by the total data set here, which in this case here we have 1, 2, 3, 4, 5, 6 data points, and that gives us 6.83. The other method here is to say y bar. So I'll do this for y, is I'm going to click average, bracket, I'm going to highlight all those data points. Make sure you don't highlight the sum, otherwise it's going to throw off your data point. So we have these two data points here. So I'm going to try to play with two decimal places here like this, and I can bring that one out like that there. So next what I'm going to do here is I'm going to want to go equals 5 minus, now here's a trick here, because we're going to want to drag this down and we don't want it to steal or keep going down on every box. I'm going to put a dollar sign, and then I'm going to click this box here, and did that work? No. Okay, so I'm going to click on the box here. Now what I have to do here is I have to put a dollar sign in front of the C, a dollar sign in front of the 12. So what that does now is it means that it's going to stick with that data point the whole way down. Conversely, I could have typed in 6.83. And then I drag it down, and it takes care of it all for me. Next, I'm going to square all those data points. I'm going to start by clicking on this one here. I'm going to hit the square root button. I'm going to hit the exponent button. Then I'm going to hit it 2. It's not the square root button. This is way too many data points. Let's take it down so that we'll keep it at 2 data points. So just clicking this button here, and then that automatically rounds for us. And we can just drag this whole thing down. Now, if we want to do the standard deviation of x, I can do the variance of x, and then the standard deviation of x. So the variance of x, now again, we're generally always dealing with sample data in data management. So what I'm going to do here is I'm going to type in equals, and I'm going to click the sum of x minus x bar squared, and I'm going to divide it by n minus 1, and in this case is 6. 6 minus 1 is 5. Then I'm going to take that data point there and I'm going to square root it. So we can hit square root, SQRT, bracket, and then hit that box above, or you can just do it to the exponent 0.5. Either one of those does the exact same thing. Now we can do the same thing for y bar. So I'm going to go y bar equals 12. And now what I can do here is, see this here cell is called C13. I can hit minus dollar sign C, dollar sign 13. And then I can drag that whole thing down. Voila. Now, if I didn't do that, let's just say that I didn't do that, it wouldn't work because I'd go the y point minus, and then what it does is it assumes that it needs to keep going down on this data point here. So it's kind of a mess here. This one here would be 6 minus this box here, which is nothing, which gives us 6. This one here becomes 8 minus this box here, which is 12.16, which gives us the rounding here, negative 4.178 minus. So that's why we put in those dollar signs. So I just go $, $, I want the $sign on C, $sign on 13. That means don't move from row C and, sorry, don't move from column C and don't move from row 13. And drag down, voila. Generally, you know you've done it right if you're getting 0 here, because the sum of all the deviations should add up to 0. Next, what I want to do here is I want to square all these data points. So I do that. And now I am ready to find my variance of y. So I'm going to go my sum of y minus y bar squared divided by 5, n minus 1. My standard deviation of y equals, take this value here, you can either put SQRT bracket that column there, or we can just take that cell there and just go to the 0.5. Voila, now we have both of them. So we have our standard deviation of x, we have our standard deviation of y, but if you can recall, the formula for the correlation coefficient is equal to the covariance divided by the standard deviation of x times the standard deviation of y. So we need the covariance. So the covariance is just equal to x minus x bar times y minus y bar, which gives us equals. Now I'm going to hit that star button on my keyboard, and I can multiply them, go all the way down, and voila, there's our covariance there. Let's bold this column here so we don't get confused. Next, so covariance of xy just tells us how are they varying together. So we're going to go equals 6.5 divided by n minus 1, in this case is 5, so it gives us a covariance of 1.3. So lastly, here we want our correlation coefficient, which is our R value. And our R value, we're going to take the covariance, divide. This is important, you got to put a bracket here or else you could wind up with the wrong final answer. This cell here, the standard deviation of x, times the cell here, which is the standard deviation of y. And voila, we get a correlation coefficient of 0.0959. Or if you want, you can round that a little bit to 2 decimal places, and you get 0.10. Which, if we've been taking data management, we would classify that as a weak positive correlation. So that's basically how this works. It's just sort of an introductory sort of lesson there on how to go about calculating a correlation coefficient for a set of 2 variable statistics. I hope that this was helpful. All right, thanks.